There are two ways you can create a trace network: by importing a geometric network or creating a new trace network. Now, before there were trace networks, there were geometric networks, and trace networks are replacing geometric networks. So if in a previous version of ArcGIS you created and or are maintaining a geometric network, you can use the Convert Geometric Network to Trace Network geoprocessing tool to upgrade your geometric network to a trace network. You can also create a trace network from scratch by using the Create Trace Network Geoprocessing tool and inputting a line feature class as your edges and optionally a point feature class for your junctions. Trace network elements include edges and junctions. The edges are created from line features, and they can be simple edges that begin and end with the junctions at the node. So all of a resource travels from the begin junction to the end junction, or as complex edges that allow mid-span junctions that can bleed off your resources as it traverses your edge. Now, junctions are created from point features, and that can be a point feature class that is set as input junctions in the Create Trace Network Geoprocessing tool, or you can leave that off and have the geoprocessing tool automatically create the junctions at line nodes. Additionally, you can create trace network attributes that control how a resource traverses a network or act as weights to model flow cost of the resource across the network. If you look in the geoprocessing pane in the trace networks tools, you can see the Create Trace Network geoprocessing tool, as well as the Set Network Attribute geoprocessing tool. And once you've created the trace network, you can open it in your map view, and there you can see a simplified trace network that includes the edges as blue lines and the junctions as gray points. Once you've created your trace network, you need to connect the trace network elements, and we do this by enabling and validating the network topology. We enable network topology to establish connectivity between network elements based on the geometric coincidences of the coordinate geometry. And you must enable your network topology to perform analytic functions or create network diagrams. We also set the flow direction, and this is specified at the feature level with digitized direction, against digitized direction, or as indeterminate, which it doesn't know which way the flow is going. And then we can display flow direction to symbolize flow with arrows. Last, we need to validate the network topology, which syncs the feature geometry and the network topology. We need to validate when we first create the topology, but also anytime we edit the underlying feature geometry. Now, if you look on the right, you can see in the geoprocessing pane in the trace network tools, the enable network topology, validate network topology, and set flow direction geoprocessing tools. And if you look in the map view below that, you can see that we have both enabled and validated the network topology as visible in the message that we see in the top right-hand corner of the map view, and also set and symbolize the flow direction by the arrows that are flowing downstream through the network. Once you've established network connectivity, you're now ready to analyze a trace network, which will allow you to select features based on connectivity or traversability across a network. Now, we analyze paths in a trace network by tracing connectivity or tracing connectivity and traversability. Connectivity is across edges and through coincident junctions. Connectivity and traversability is across edges and through coincident junctions, plus any network flow configurations you've set, like barriers or network attributes like flow cost. Now, we begin a trace by first creating and snapping a starting point to a network, and then we can run the trace geoprocessing tool in the geoprocessing pane in the trace networks tools toolbox. Once you open it, you need to select the trace type, which is connected, upstream, downstream, or shortest path. And so connected selects all the edges connected with the starting point. Upstream selects all the edges against flow from the starting point. Downstream connects all the edges with flow from the starting point. And then shortest path selects the shortest series of edges between two starting points. And if you look in the map view in the lower right-hand corner, you can see that I've set a starting point about halfway up the network, and I've run a downstream trace. So it's selected all the edges that go with the flow from the starting point. Last, once you analyze your trace network, you can actually diagram your trace network as well. which helps explain the network structure and the way it operates. It's just a schematic representation of the network. And if you look on the right-hand side, you can see I've got the actual network in the top image, and in the bottom image, I've created a network diagram of that same network. And so the diagram represents the network in a defined space without scaling constraints, and the benefits of creating a diagram include creating logical flows that are easy to understand, representing multiple network levels at the high level and then all the way down in a high resolution, and then checking your network connectivity. And you create a diagram after you create a trace that selects your network. Then on the context sensitive trace network data ribbon, you click in the selections group, the apply to diagrams button to create a network diagram of your trace solution. In closing our discussion of network analysis, we can use vector networks to model connectivity and how agents traverse a network, and to answer questions like, what is the fastest route from home to work? Are property boundaries coincident? And which valves must be turned off to fix a broken main? And we can apply the analytical process, question, inform, analyze, decide, and present to perform a network analysis. For example, the question, which is to frame the connectivity routing problem, and then we inform our analysis by modeling the logical network and properties. Next, we analyze our network by analyzing and solving the network problem. Then we decide on what our findings are saying and refine our analysis. And last, we present our findings by quantifying and visualizing our results. Now, the vector, proximity, overlay, and network analysis tools that we've been talking about over the past few weeks are really just the tip of the iceberg. There's over 600 geoprocessing tools packaged up with ArcGIS Pro. And if that's not enough, you can actually go to the code sharing sites to find custom scripts, tools, and more. And I never, ever try to create something from scratch. A lot of times I'm like, I really want to do this, but I can't figure out how to do it. Well, then I've gone to these code sharing sites, and almost always somebody has already replicated what I want to do. And I can just download the code, import it as a tool into my geoprocessing toolbox, and run the custom geoprocessing tool that I need to complete my project. All right. So once you've completed the lecture demonstration, the project, and the quiz, you should be able to identify the basic network structure elements, including edges, junctions, and connections. Distinguish between topological, directed, and undirected networks. A topological network models connections between features. Undirected networks model connections between features that flow in both directions. And directed networks model connections between features that flow in one direction. You should be able to explain the difference between topological, transportation, and utility networks. Geodatabase topology includes one or more integrity and/or feature class behavior rule that models real-world connectivity. Map topology allows you to create shared edits in an ArcGIS Pro edit session. Transportation networks allow you to model a transportation system like vehicular or pedestrian. And a multimodal transportation network allows you to model multiple and connected transportation systems. Last, a utility network is a directed network that allows you to model utility or telecom systems. You should be able to describe how to create and analyze a trace network. And in the lecture demonstration and the star-based impact assessment, you'll create and analyze a trace network.